So in this video we are going to solve this problem. So in this problem it is giving that suppose f of x is equal to mod of log of x plus 1 and a and b are real numbers which satisfy this equation and this also, then we have to find the value of a and b. So it is giving that f of x is equal to mod of log of x plus 1. So and this condition is given, so you can put x is equal to a in this and x is equal to minus of b plus 1 divided by b plus 2 in this. So you can then equate these both two. You can simplify this is equal to 1 divided by b plus 2, so it will become this. You know that log of 1 divided by b plus 1 is equal to minus of log of b plus 1 divided by log of 1 divided by b plus 2 is equal to this minus, but you are taking mode, so it will become this. So there are two possibility here. Either this will equate to this, like there are two solution here, like Lg of a plus 1 is equal to plus minus Lg of b plus 2 after removing mode. So if you take plus sign, then this condition will come, and if you take minus sign, then it will become like this: log of a plus 1 plus log of b plus 2 is equal to 0. So by the log property, this should be the sum will convert into the product, and this product value must be 1 for log to b is equal to 0. So this case, so in the question it is giving that we have this condition like this: a is less than b. So if a is less than b, then a plus 1 is less than b plus 1 and it is less than equal to b plus 2. So this case cannot be happen like this case, so we disregard this. So case remaining is this. So now we have f of a is equal to this. So we know that the argument inside the log is this. So argument should be greater than 0, must be greater than 0. So we put this greater than 0, and now we know that a is less than b. So a plus 1 is less than b plus 1 and it is less than b plus 2, and a plus 1 must be greater than 0. So we have this condition. Now you can see that, so in the problem one more condition is given. So this condition is also given in the problem. So we can find this, like this value tan a plus 6b plus 21. So we have to find tan a plus 6b plus 21. So and function is log of 1 plus x mod is equal to f of x. So if you put this x value here, so we can look at this value here. We are adding plus 1, so I am adding plus 1 here also. Then you can take 10 times, you can split it into 12, like you can split 21 into 11 plus 10, and this 10 you can combine with this. So 10 you will take common, then it will become like this, and this 11 and this will become 12, and 12 plus 6b, so 6 common, then it will become b plus 2. So like this. And we have given the condition like a plus 1 multiply by b plus 2 is equal to 1. So from here you can write b plus 2 is equal to 1 divided by a plus 1. So 6 times b plus 2, so this term is here, and instead of a plus 1 you can write 1 divided by b plus 2. So this will this, and it is in the inside the logarithm, so this argument should be greater than 0. This is the first thing. And in the problem it is given that it is equal to the 4 times Lg2. So in the problem it is given that it is equal to the 4 times Lg2. So this thing is positive, this thing is positive, we know, so this thing must also be positive. So we remove mode by positive sign. So this thing is positive, so for uh, this thing is also positive, but it can open in two ways, like plus minus. So which sign we would take? So it will depend on this value. So this value is greater than, uh, so we have to, like you see here, this is 6 times b plus 2 and this. So previously we have written this condition like uh, a plus 1 is greater than 0 and b plus 1 is greater than this and b plus 2 is greater than this also. So so in the problem you can see uh, we are getting b plus 1 it positive. So this quantity is something positive, and if you add 1 to this, so this quantity 1 plus b plus 1 should be greater than 1. So this quantity is greater than 1. So if you multiply this quantity 6 times b plus 2 something, so it will become greater than 6 something, and we are also adding something to this. So this whole quantity is greater than 1. So if the log argument inside the log argument is greater than 1, then its value is positive. We know that from the log property. So this whole argument is greater than 1 and its value is positive, so we can easily uh, open this logarithm in two ways, like log of 6 of b plus 2 plus 10 divided by b plus 1, oh sorry, 10 divided by b plus 2, and so this, and this equal to the 4 times lg2. So from here you can take to the power this, so it will become log of 16. Then you can equate these both two. So after making quadratic 6 times b plus 2 whole square minus 16 times b plus 2 plus 10 is equal to 0, you can find the value, possible values of b plus 2, like minus b plus minus root of b square minus 4ac divided by 2a. So b plus 2 value are come like here, you can positive sign, it will become like 20 divided by 12, and if you take negative, so it will become like this. So one is one case it is coming 1, and in one case it is coming 5 by 3. So possible values of b are 1 minus 2 and 5 by 3 minus 2. So these are two possible value which is equal to minus 1 and minus 3. But in the problem we know that, like we have condition a plus 1 is greater than 0 and this should be greater than b plus 1, like we have this condition, and if you put b is equal to minus 1 here, then b plus 1 will become 0, which is not true. So we will discard this case and we will take this case, b is equal to minus 1 by 3, and we have this condition also. So if you put minus 1 by 3, then it will become 5 by 3, so a will become 3 by 5 minus 1, so it will become minus 2 by 5. So a value is minus 2 by 5 and b value is minus 3. So this is the correct answer. So in this way you can find the solution of this problem.